Regression plot in Python using Seaborn. In our earlier lessons, we have learned to plot various types of charts such as scatter plot, line plot, pair plot, joint plot, heat map, etc. In this lesson, we will learn various ways of plotting regression lines using Python Seaborn. Before we proceed, let's have a brief introduction to regression analysis and regression line. So, what is regression analysis? Regression analysis is basically a set of statistical methods used for analyzing the relationships between a dependent variable and one or more independent variables. It has many variations such as linear, multilinear, and nonlinear regression analysis. In simple linear regression analysis, the relationship between a dependent variable and an independent variable is analyzed. The relationship between the variables is shown using the following equation. Y equals a plus bx plus epsilon, where y is the dependent variable, x is the independent variable, a is the intercept, b is the slope, and epsilon is the error or residual. Here are the variables of the equation, y equals a plus bx plus epsilon. In this lesson, we won't go into the detailed calculations, rather we will jump straight into the plotting activities using Python Seaborn package. Let's start with a simple data frame with two columns x and y. Let's plot a scatter chart using the x and y columns of the data frame df. Now run the code in the terminal and see the result. And here is our scatter plot. We can clearly see that the value of y increases with the increase in the value of x. We may also fit a line to connect the dots. Unfortunately, all the dots will not fall on the line, but we can draw such a line that minimizes the distances of the dots and the line. This is the concept of least square regression line. We have already learnt the basic concept of least square method of regression line. Now let's use the Seaborn regplot function to plot a regression line using the same data frame. Look, the regression line drawn by the regplot function is almost the same as the one we had drawn on scatter plot. Interesting, isn't it? We may also use the lmplot for plotting the regression line. And here is our regression line. Isn't it almost similar to the plot generated by the regplot? Yes, with minor differences in the appearances. Notice that the top spine and the rightmost spine is missing in this plot. We may also use the jointplot function for the same purpose, but we will try it after some time. Now let's consider that we have data in a CSV file, ice_cream_sales.csv. The file has two columns, temp and sales. We will create a data frame from this CSV file and plot the data frame using lmplot, regplot, and jointplot functions one by one. So, let's change the code to create a data frame df from the CSV file. Here we will use the pandas read_CSV function for reading the CSV file. We also need to change the column names in accordance with the CSV file. Look, the CSV file has two columns, temp and sales. And here is the plot generated by the lmplot function. Now let's use the regplot function. And here is our regression plot. Let's set the theme of the plot. Here is the plot with a dark theme. Let's see the output of the lmplot function with this new theme. Now we will generate a joint plot using the same data frame. The output of the joint plot is shown on the screen. The main plot is actually a scatter plot. We need to pass the kind argument to the joint plot for changing the plot type. Kind equals reg generates a regression plot. Now, in addition to the scatter plot, we also see the regression line. So, we have learned that we may use any one of lmplot, regplot, or jointplot functions for generating regression plots using Seaborn. Now we will learn how to modify the appearance of the regression plot using various parameters. Let's first concentrate on the regplot function. Let's change the line color with the line_kws parameter. We can also change the color of the scatter plot markers using the scatter_kws parameter. We may also supply the alpha value for the colors. Alpha controls the opacity. Alpha value of 1 means fully opaque and alpha value of 0 means fully transparent. We may also set the confidence interval using the CI parameter. A confidence interval refers to the probability that a population parameter will fall between a set of values for a certain proportion of times. Look, the brown shadow behind the red line is the area for confidence interval. We may also set the marker for the scatter plot using the marker parameter. The regplot function returns an axis object. Let's assign the axis object to a variable ax. We can use this variable for setting various attributes of the axis object, such as title, x label, y label, etc. Now let's consider the lmplot. Here we will use the penguin dataset of the Seaborn library. Let's view the top 5 rows of the dataset df. The penguin's dataset has 7 columns such as species, island, bill length, flipper length, etc. Let's plot the regression line using the bill length and flipper length columns. Here we will use the lmplot function. And here is the plot. So many data points, and the best fit regression line with confidence interval shadow. Now let's add the line_kws and scatter_kws parameters. We may also pass the hue argument for splitting the dataset into different colors. The hue parameter plots a separate regression line for each subcategory of data. Here we have set hues to species. So, we see 3 different regression lines for 3 different species of penguins. We may also use the call parameter for plotting regression lines in separate columns for each subcategory of data. Here call equals species plots regression lines for each species of penguin in a separate column. If we pass both of the call and hue parameters, separate columns will be used for each subcategory of data. Also, separate regression lines will be plotted in different colors based on the hue subcategory. Here separate columns is used for each species, and separate regression lines have been drawn for different sex within each species. We may also pass the row parameter for splitting the data into different rows for each subcategory of data. Here row equals sex will split the data for male and female in separate rows. Look, here the top row is for the male penguins and the bottom row is for the female penguins. We may also use the markers parameter for drawing the scatter plot in different markers for each subcategory of data based on the hue parameter. As the dataset consists of 3 different species of penguins, we need 3 different markers. The types of markers are as per our choice. Notice the markers circles, triangles, and asterisks for different species. Now let's modify the code to plot a regression line for the same dataset using jointplot function. Here the kind parameter is important as we have to mention that we need to plot a regression line. Here is the output. Note that, in case of a joint plot, the regression line is accompanied by the distribution plots of the variables, bill length and flipper length. Seaborn is a very versatile and powerful library for plotting. We have a variety of options for plotting in different ways. Now we will see how to use the pairplot function to plot regression lines for each combination of numeric variables in a dataset. Notice the regression plots in the upper triangle and the lower triangle for each pair of numeric variables, bill length, bill depth, flipper length, and body mass. We may also add various other parameters for modifying the appearance of the plot. You may watch the lesson on joint plot and pair plot as linked in the I button above and in the description for more details. Until now we have plotted linear regression lines only. Both the lmplot and regplot functions allow us to plot regression lines of different orders. Let's check these one by one. By default, the order value is 1. This is our order 1 regression line. Now let's change the order to 2. And here is our order equals 2 regression line. Look, the regression line is no longer straight, it's curved. Now let's switch to regplot. We may fit a robust regression line to downweight the influence of outliers as shown here. Robust equals true fits a robust regression line by downweighting the outliers. Log x equals true fits a log linear regression. Lowest equals true uses a locally weighted or lowest smoother for fitting the regression line. Look how different the regression line is after applying the lowest smoother. In this way, by supplying a number of parameters, we may generate beautiful regression plots using various functions of Seaborn library. That's all for today's lesson. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.